Okay, so first of all, like a Hive and Hadoop, like we have already installed it, and that practice we are going on. Okay, we are doing already, and how to do the Spark installation. Okay, so for Spark installation on Ubuntu, we have to download the Spark zip. Okay, so Spark download. Okay, so if you go to the Spark download here on the website, so this link. So here we have to select the Spark version. Okay, and we can select the Spark 3.3, this one. Okay, so this option we can choose. We can choose this option and then download this star file. Download this star file. And once you download this star file, so I kept it in the my software folder. So I created separately software folder, and there is already mine folder is Spark 3.2.3. So you have to copy this folder, whatever folder you will download, whatever zip you want to download. So just make it, rename it to Spark 3.3.1. Okay. So mine is Spark is 3.2.3. So this this path you have to set it in the bash rc. So nano dot bashrc. We come to here. So I set here Spark underscore home. So these two paths you have to set in your bash rc. Okay, so I'm copying it. So once you download this, copy the Spark hyphen 3.3.1 into software. Okay, and set the Spark home path in bash rc. Okay, so you have to do the command $nano. So $nano bash rc. So when you do this one, so you have to copy this path at the end, and then you have to do the source command. Source. So you have to do Control X, Shift Y, Enter. Okay, Control X, Shift Y for saving it, Shift Y, and then Enter. Okay. So this, so first you have to download go to the website, download the tar file, unzip it, and copy into the softwares folder. Copy in the softwares folder in home, and then open the nano bash rc. Copy this path and change your one, because this is my username, but you change your username here. Okay, change your username, and then you do the source command dash rc. So this is a way, and after that you have to start the Spark hyphen shell. Okay, if it is a Scala version. Okay, Spark Scala. For PySpark, you have to type PySpark. PySpark. So you have to type PySpark, then you will get Python Spark. Okay. So I'll show you. Mine is already done. Okay. So here I'm typing PySpark. So I'm getting a PySpark shell. So this is PySpark shell. Okay. Here Spark context, Spark session. Okay. So this is PySpark. And when I do, and then I do Spark hyphen shell, so it will start the Spark Scala shell. So Scala prompt will come. Scala prompt will come, and here we can write a Scala program, like a Spark Scala API. Okay. So I will just first start like what is the Spark and all those things. I start the concept first, and then I will show the practical. Okay. Okay. So this is all related to installation. Okay. So this part is related to installation. Okay. Next week, I will do some workshop on the AWS. So next week, I will be doing the workshop on AWS Big Data Spark Hive project. Okay. So I will show this project. So that is the reason I'm covering Spark, little bit Spark, so that you can get the idea. Next week I will do this AWS services project. So how to use AWS, AWS Hadoop Spark Hive project. Okay. So that will be using the cloud and using the Spark and using the Hive. Okay. So first of all, what is Apache Spark? Okay. So Apache Spark, we have already seen MapReduce and Hive. Okay. So these two are analytics frameworks. Okay. But these two are Hadoop based analytic framework. Okay. So they are tightly coupled. They are tightly coupled with Hadoop SDFS. Tightly coupled with Hadoop SDFS, the storage. Okay. So suppose I have some data. But I want to do some analysis. I want to do some analysis. I want to do some analysis on this data without Hadoop file system. Analysis without using Hadoop file system. So I cannot use this MapReduce and Hive. So Apache Spark is a framework, is an analytic framework, which is extension of MapReduce and Hive, and providing in-memory computation. So what is in-memory computation? Means your execution is not a batch. So batch is also supporting, Spark is supporting batch plus real time. Okay, real time processing both. Okay, but even for batch also, it is processing data in memory. That is the reason processing it is doing in memory. That is the reason it is the execution is faster. That is the reason execution is faster. Okay, so Spark is 100 times faster in memory. If any processing it is doing in memory, it is 100 times in the MapReduce memory than MapReduce. Okay, and 10 times faster in the disk. Okay, even it is doing simple batch processing using disk, that is also 10 times faster than MapReduce. Okay, so Spark is first advantage is it's a in-memory computation. Second one is Spark is giving DAG form, right? Basically it is basically maintaining the DAG. So what is a DAG basically? DAG is direct acyclic graph. Direct acyclic graph. That is basically maintaining state of operation in DAG form. Okay, so any point of time, if any operation got failed, so it will not start from the scratch. So already computation is there, right? In the DAG, already computation is there in DAG. So it is fault tolerance. Okay, and so this Spark is based on the RDD concept. Spark is based on RDD, resilient distributed data set. So what is here resilient? Resilient here the fault tolerance. So resilient means Resilient is fault tolerance. So any point of time it can recalculate the data, okay, without like it will not start from the scratch. And distributed means parallel processing. So parallel processing in distributed environment, okay. And RDD is immutable collection of data. Immutable collection of data, which is immutable collection of data, which is spread across the worker, across the workers. Okay. So main advantage of Spark is we don't need Hadoop file system. Suppose I want to run Spark standalone, so I can run Spark in standalone. So Spark has 3 cluster manager. 3 types of cluster manager support is there. 3 types of cluster manager. So cluster manager, I will tell what is a cluster manager. One is Yarn cluster manager. Second one is standalone. And third one is Mesos. Okay. So Mesos is another server is there, and Yarn is Hadoop based. So Yarn is Hadoop based. So when I want to do Hadoop based processing, right, my data is on Hadoop and I want to run my Spark job, I will use Yarn cluster manager. So Hadoop based. Okay. If I want to run a Spark job standalone, my data is not required to store in Hadoop, so I can use standalone. So there is no need of Hadoop file system, SDFS. And Mesos is another kind of server, for distributed environment. So for that we use this Mesos. Okay. So these are the 3 types of cluster manager. And Spark has, what is a Spark architecture? Okay. So Spark architecture, so Spark has a driver program. So we already seen in MapReduce also having the driver program. So what is the role of driver program? So driver program is an entry point. It is an entry point of your application. Entry point of application, which is submitted in the cluster, and execution will start from here. Okay. The execution will be start from here. Okay. So driver in Spark, the driver, once the program is submitted, so driver calls cluster manager, and cluster manager will decide. Cluster manager will be decided based on the configuration. Okay. So when I'm doing my Spark submit job, when I writing a like Spark submit, I tell the parameter here minus master, and I'm telling here my master is a local or Yarn, and I'm telling about deployment mode here. So that property is either client or cluster, okay, or some other properties are there. So these properties I'm doing in the Spark submit. So basis of these properties, driver calls the cluster manager, whether it's a Yarn cluster manager or standalone. Okay. So cluster manager will be called either Yarn cluster manager, Yarn or standalone. Okay. And this cluster manager will allocate task to worker executors. Okay, what is executor here? Executor is a execution unit. Every workers have the executors are there. So we know the concept of like cores, executors. Okay, so cores are CPUs. Like we say 10 CPUs machine, 10 cores machine, 12 cores, 14 cores. So it's a CPU, like multi-processing unit. Okay, that is cores. Executors means the worker has some execution engine that is called executor. And this executors are executing task. Okay, we know right in the Hadoop concept there is a node manager and resource manager. So resource manager is managing the resources and allocating the task to the node manager, and node manager is doing the actual task. In case of Hadoop framework, right, MapReduce and Hive. Okay, but here in the Spark, here is worker is similar to the node manager, and worker is having the executors, and executor is doing the actual task. Okay, So when we say here driver is the entry point and application which is submitting in the cluster, the execution will start from here in the driver program, and driver calls the cluster manager, which is yarn or standalone, which is allocating tasks to the worker executors. Okay, and executors are performing tasks and getting result and return back this result to cluster manager, and cluster manager will return back to driver, return back to the driver. So this is actual Hadoop. This is actual Spark architecture, right? How the Spark is managing the things. Okay. Okay. So far it is clear, right? What is Spark? What are the types of cluster manager? Okay. So they are the two types of deployment mode I'm talking about here. Okay. What is this? So one question is coming here. What is a deployment mode? So deployment mode, either client or cluster. So when I say cluster deployment mode means when driver program is running in yarn application master remotely. Okay. So this driver program is not running on your local machine. This driver program is running on remotely, it is running. Okay. So that mode is called cluster mode. Generally, this is used for Hadoop file system. Okay. So because yarn comes in picture when we are talking about the Hadoop file system. Another one is a client mode. The client mode is when driver program running locally. Driver program is running locally, local machine. Okay. So when the saying client mode is when the driver program is running local mode, and mostly it is used in standalone processing, right? Standalone, when we are not using Hadoop file system, and we are not using Hadoop file system. Okay. So these are the two different modes, and we decide based on the what type of processing we are going to do. Okay. So when we start the Spark, right? So first of all, like Spark, how to create this RDD? We are talking about this RDD. So what are the different ways to create RDD? What are the different ways to create RDD? Okay. So there are the two ways are there to create RDD. One is when you are reading any unstructured data. When we are reading unstructured data, then it is creating RDD. Unstructured means like text file data, not image or audio video. I'm talking about here unstructured means this is unstructured data. Here is nothing structured. Can we find there is a symmetry here? No, right? One line has 5 words, one line has 20 words, one line has 2 words. So this is unstructured data. So text file data is a unstructured data. But if I say CSV file, JSON file, this is structured data because the data is a columnar file, like specific structure form, right? Like if I talk about the CSV file, JSON file, XML file, so these are called semi-structured data. Semi-structured data, but structured type. Semi-structured file, but structured data. Okay. So this kind of data is, so when we are reading this type of files, it is giving data frame. Okay, not RDD. But when we are reading a text file, unstructured data, like text file, then it is creating RDD. That is a one way. Second way to create RDD is when I have some collection like array, set, map, and I use some function like parallelize function is there, parallelize. So this parallelize function, when I pass this collection like array collection, then it will give me the RDD. It will return RDD. So RDD is a basic fundamental unit of Spark, which is measuring any data, which is doing measurement of any data. Okay. And once we get RDD, then we can perform some operations. We can perform transformations. So what are these transformations are there? Transformations. So there are the different transformations are there: map, flat map, filter, join. So right, these all types of operations generally we do on the data, right? Join, group by key, reduce by key. Okay. And some actions are there. What are the actions? Action is generally used for getting the final result. What are the actions are there? Count, for each, collect, okay, and reduce. So these are the actions. So when I call action, all transformation will trigger and then it will give the final result. So how to differentiate what is a transformation and what is the action? So there are two types of operations types are there in RDD. So two types of operations. One is transformation, second is action. So transformation, we define it. Transformation is when we do any operation on RDD and get a new RDD. Rather than modifying the same RDD, we get the new RDD. So that is transformation. And action is giving us final result. So there further you cannot do any operation, final result. So suppose I did count function. So count is an action. So when I do count, I say rdd.count. So I will get some value. I will get, okay, 4. So 4 is how many number of records are there in my RDD? I will get 4. And further I cannot do anything. But suppose if I am doing map, flat map, so one transformation to another transformation we can call. Okay. But when I call one section, we cannot do any further transformation because it will be giving final result. Okay. So that is the difference between the transformation and action. Okay. So transformations are different types of transformations are there. Transformation is conversion, like one form to another form you want to convert, that we use transformation. Okay. I'll give an example. Okay. Suppose I have an array. I say array of 5 values. Okay. So this array has 5 elements, 1, 2, 3, 4, 5. I say I want to apply some map function and each element of array I want to multiply 2. So how can I do? I will use my array dot map and x is a lambda, right? Here I'm saying each element you pick in the x and do multiply of 2. Okay. And then you get a result. So what the result of this will come? It will give another array 1. It will give another one array, that is a RDD, and this array 1 have the values like this. So this array 1 will be having the value is, what will be the result of this? 2, 4, 6, 8 and 10. Because after multiplying the element, I will get this array. So this is called map operation. So map operation is one-to-one operation. Each element it takes from the RDD and do apply the operation, whatever operation I'm doing here, multiply 2 and give the same number of element. Okay. So what is map here? Map is one-to-one operation. One-to-one operation, and it is giving same number of element in your RDD, same number of element in resultant RDD. So your resultant RDD, you will get the same number of element. So that is called map operation. What is flat map? Flat map name is flatten. Flat map is flatten. Flat map is flattening the element. Flattening your input element and giving single array with all elements. Okay. So suppose if I say I have an array 1. Okay. Here is I have array of multiple arrays are there. I say array of, okay, so I say 1, 2, 3, 4. This is one array. comma, another array, 5 comma, 6 comma, 7 comma, 8 comma, 9 comma, 10. So this is my second array. So if I apply here flat map, what will happen? If I say here array1 dot flat map and I do x of lambda, okay, I say if I do the flattening of the data, so this flattening of the data will be giving me all element in a one single array. Okay, so when I do split, okay, and then I will get the result. So suppose this all element are one array and another array is also second array. So I will get the final array which will have all element in the, so array 2 which I'm creating from this. Okay, this is array 2 and array 2 is have all element in a single array of all element. So when I get the need of flat map, when I get the need of flat map, when I have a requirement to merge the two arrays and create a single array. So in that case, I will go flat map. So flat map is taking a less number of element and creating more number of element. Okay, so here it took two element, like one array and second array, and create a more number of values in the one array. Okay, so this is a flat map. Another is filter is there. One transformation is filter. So filter is very simple. Suppose I say I have a 10 element is there. Okay, so I have a array of 10 values. Okay, and now I want to get the even values of this array. So array 2 I'm creating and I want to filter off even values. So I say array 1 dot filter and I want to find out which is even value. So I will use the modulo operator x% equal 0. Okay, so whichever value is equal 0 means remainder is coming 0. So those values I want to filter out. So what will be my result here, array 2? So array 2 will be only 5 values will come, 2 comma 4 comma 6 comma 8 comma 10. Okay, so this kind of transformations I will show you how to read a file, how to do these transformations. So this is basic example of transformations and actions. Okay, so action is like if I give the count, so count will be giving me the count number of values in the array. Okay, so that will be giving me the count. Okay, so Spark has how many modules are having Spark? So Spark has different modules are there. Spark Core, Spark SQL, Spark Streaming, Spark Machine Learning, ML, and Spark Graph. Okay, so these are the 5 modules are there in the Spark. How many languages are there used in Spark? So Spark is using the different flavor of languages. So Spark can use Spark with Scala. Okay, why Scala is a native because Spark is written in Scala. Okay, so Scala is a native language. So when you are writing a Scala program, when you're writing Spark Scala, that is faster than PySpark or Java, Spark Java. Okay, so that is the reason mostly applications are written in Scala, but some Python also there. Sometimes PySpark programs are there also, project also there. So the reason is PySpark programs are like machine learning. So they can use MLlib or Python-based libraries. Python-based libraries, right? So some Python-based libraries name pandas, okay, SciPy, okay, NumPy, okay. So these are the scikit-learn. Okay, so these are the libraries, are the Python-based library. If you are using the PySpark, you can use those library in your Spark code. So some machine learning data science project are there in Spark. They use PySpark as a Python language. Okay, And another one is Spark Java. So very rare case, like people go for Spark Java. Generally, the Spark Java is used when they are already using Java application. They are already using Java Spring Boot application. Spring Boot application for microservices. For microservices. Okay. So then they go for Spark Java. Okay. Because they want to use the Java API in their Spark program. So they use the Spark Java. Okay. So they are the different choice are there. Either you can use Spark with Scala, Spark with Python, Spark with Java. And another one is there Spark with R also there. Like suppose you want to write a R programming language code, R programming language code, we can use Spark with R. Okay. So Spark has the first fundamental unit is RDD. On top of the RDD, like we use the data frame, and data frame and RDD and data frame combination is data set. Okay. So these are the three types of APIs are there in the Spark. So Spark using three types of APIs. Okay. So either, but these APIs can be we can write the program either using RDD, data frame, data set. All three are supported. Okay. And Spark has 5 modules. So Spark core is a base. Spark core is a base module which has transformations and actions. Okay. So transformation and actions are the in the core module. And on top of the Spark core module, Spark SQL. Spark SQL means reading the data and writing the data to the different data sources. Reading and writing data to different data sources. So what could be the data sources? So one like a file system, like any file system data, right? CSV, JSON, XML, CSV, JSON, XML, or SQL databases like Oracle, MySQL, DB2. These are the SQL or NoSQL databases. NoSQL databases. So we have the examples of NoSQL databases like Mongo, Cassandra, HBase, Mongo, Cassandra, HBase, Elasticsearch. So these are different integrations are there. So when I say like I'm reading the data from some files, some SQL or NoSQL, or writing the data to the files, NoSQL, SQL. So this is completely the Spark SQL. And here in the Spark SQL is data frame API. Data frame API. Okay. When I talk about the Spark core, this is using mostly RDD. RDD we are using. Okay. So why we are using data frame here? Because whenever you are read any type of these sources, every time you will get the data frame only. Only RDD we get when we are reading the text file. When we are reading text file data. Text file data is unstructured data. Okay. Then we are getting RDD. But this RDD we can convert into getting RDD. But this RDD we can convert into data frame. So there is a function is there, data frame. So we have some function is there 2df. So RDD dot 2df, that is converting to RDD to data frame. Okay. And data frame to RDD also we can convert. So there is a function df dot to RDD. Okay. So either way we can do, vice versa. Okay. Another one is streaming APIs is there. What is a streaming? When we are reading real-time data, like a Twitter data, streaming data, or some credit card swiping data, or data which is coming from streaming. Data is coming some live streaming sources, So it could be anything, right? It could be anything which is coming on time, real time. Okay. So here is we do Spark with Kafka streaming. So Kafka will be the tool we will use here for integration with Spark with Kafka streaming, socket Kafka socket Spark streaming, and file streaming also. So there are the couple of examples are there. Machine learning is completely completely related machine learning libraries. Okay. So this and graph is basically where we use ages and vectors, ages and vertices. Okay. So these two are mostly not used like as a data engineer, because this all are related to machine learning data science. So our main focus is to work on these all three: Spark Core, Spark SQL, and Spark Streaming. So we will be see the different use case scenarios, how to use Spark Core, how to use Spark SQL, and how to use Spark Streaming. Okay. So far this clear. Okay, I just show you some example, right? Okay, first we see Scala one, and then I will show the PySpark one. Suppose I have some file in my local file system. Okay, suppose I have a file. Okay, so suppose this XYZ file is there, and this file I want to read. This is unstructured data, right? So okay, but first of all, we have to learn the Scala as well, because basic Scala programming language we should know. So Python or Scala, they are the two choices are there. Okay, and both also we can learn. But at a time, if someone working on the Scala, so someone cannot do more concentration on the Python. If someone is doing Python, so Scala is not, because syntax is changed. Okay, so Scala and Java syntax almost similar. Okay, so there is a similarities are there in the Scala and Java, but Python syntax is different. So someone who feels like comfortable in Python, they can start Python, or someone who feels comfortable in Scala, they can do. Okay. So at a time, both can be done, but it will be giving a confusion, right, regarding the syntax part. Okay. Or first someone can do the Scala, okay, and then do some practice on the PySpark as well. Okay. So when we are writing any variable in the Scala, so we have a val or var. Okay. So suppose I say val x equal to 10. So nothing is here Spark. It's just a simple Scala language. So val x equal to 10, I define some variable and I want to print this value of x. So I will do print x. Okay. Suppose I want to say I want to add x equal to x plus 10. So it will give the error. Why it will give the error? When you define a variable by using the val, it will give the error. But when I create a variable, like I say y equal to 20, okay. Now I create a variable using the var, and I say now y equal to y plus 10. But now this time it will not be giving error, because y is a mutable variable and val is a immutable. Okay, you cannot change. So it is giving the error. So generally you just consider, right, whenever you are creating a variable, if it is a mutable, then create the variable as a var. Or if you want to create a variable as a immutable, then you create a variable using the val. Okay. So in Scala, right, anything you want to assign is like in the Java, how to write it, like int x, like this you type. But in the Scala, there is no need of type. We don't need to define the type. It will automatically take the type. Okay. So if I say, well, x equal to hello. So now if the x type is hello, okay, string type. So automatically it detected based on the value you assign the variable. Same in Python, when you write a Python code, right, you write y equal to hello. So that variable will become automatically type of string if double quote hello you written. Okay. So, okay. So I'm creating some RDD here, val RDD, and I'm reading a text file, spark dot. So my file is in this location. This is my home location. And this file is not having any extension. Okay. XYZ. Okay, so when I do spark context dot text file, okay, spark is like a session variable. Spark is a session variable that is by default is there. Okay, but this is a Spark Scala shell. Suppose this program I'm writing in a IntelliJ, I need to create manually this Spark session. Okay, but here this is a Scala shell. This is Spark Scala shell. By default, Spark session will come. When you start the PySpark shell, the Spark shell come by default automatically. Okay, but when you are writing a program in editor, okay, I'll show you the program in editor. So you have to create manually this Spark session. Okay, there you will not get this default Spark session. Okay, from a Spark session, we can get the Spark context, and there is a method text file to read any file for any location. Okay, now I say rdd.count. How many rows are there in that file? 3, right? 1, 2, 3. So how many rows is coming? Count, I told you, it will give the number of rows. Okay, suppose I want to do, this is a one action. I just took the RDD and print the count, right? So it told me how many rows are there. But suppose I say I want to do the word count. You know, right, in the MapReduce, we did the word count, right? How many word are there? How many word are there in this text file? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 words are there, but I want to do frequency of the word. Okay. I want to get the total word. Okay. So that is I can do. So first I do, what should I apply it here? Which transformation is good first? These are the different rows, right? In first row is 1 word, second row is 3 word, and then 6 word in the next row. Okay, so if I get it all the word in a single array, then my word count will be easy, right? So how to get all words in a single array? Flat map. So I'm doing flat map. How to do the flat map? X of split by space. So my words are splitted by space. I will get all the word, and now I do count. Whatever I'm getting, I do count on this. Now how many words are coming? 10. So first, when I do the count on RDD, this RDD, I got 3. It means number of rows are 3. Now I got one more RDD, I apply the flat map, and I got a single array. If I don't do this count, okay, and I want to see, I create another RDD, well, RDD1, okay, and this RDD1, I do collect. Can you see this is the array? One single array is there. All words are coming in the single array. So RDD1 is the array which is written by the flat map, a single array. Okay. And when I apply the count on this array, I will get the 10 because the number of elements are there in this array 10. But in this RDD, if you print this rdd.collect, what happens? Rdd.collect. This is hello is 1, second, third. 3 rows are there. So 3 arrays are there. 3 elements are there in the array. That is the reason count came 3. Here count came 10 because the number of element in the array are 10. Okay. Now after this flat map, what should I do? Okay. After doing the flat map, what is the count? How to do count, right? How to do individual word count, right? Like a frequency of the word. So you know, right, in MapReduce, we did the map function, right? In the map function, we splitted the word, and each word we give in the 1 count. So first we do map function here because each word 1 count, right? So map x of x comma 1, x of x comma 1. Each word I'm giving 1 count. What I'm giving here? Each word I'm giving 1 count. This hello is 1, how is 1, r is 1, u is 1. Every word I'm giving 1 count. And after that, I do collect what I will get. Now I'm getting the pairs. I'm getting the pairs of array, right? Pairs of array, which is having each word is 1 count. So my map function in MapReduce, this is giving also the same result, right? After that, in MapReduce, there is a reduce function. Okay, but here in the Spark, we have reduced by key. Reduce by key. What is the meaning of reduce by key? Reduce by key will be doing the aggregation of the word, aggregation based on the key. So hello is how many time is there? 1. How is 2 time? R is a 2 time, U is a 2 time. Okay. And I is a 1 time, M is a 1 time. So this is my aggregation. So I will use underscore plus underscore. Okay. So here is first is a key and second is a value. Okay. After that, I do collect to check what is the result. Collect. If I do collect, now can you see your aggregation is happening here? R is 2, find is 1, how is 2. So reduce by key is doing aggregation based on the key. Okay, even the group by key also give the same thing, but I will tell you what is the difference. But group by key and reduce by key, anything you can use. Okay, so now this is kind of final result only, right? Like R is 1, find is 1, how is 2. Okay, so I can do group by key, but this is coming through collect, right? I do count. Count is giving total number of. So I can assign some RDD1. Okay, and this RDD1 I want to print. Okay, so I can do for each X dot. So what is printing? Only key is printing. Okay, now I want to print. So X dot underscore 1 means this is a tuple, right? Like list of values. List of values are there in my RDD. So I will refer to keys by using the underscore 1, and values I can refer to underscore 2. Okay. So this is my final word count program. Like, so how many lines I use here? If I say 1, I use flat map. Second one, I use map, then reduce by key. Then I can use this for each println. Okay. So only 4-5 functions I'm using. For each is here action. For each is the action here, which is, so in Spark, one thing is when you are calling action, then your transformation will trigger. It is lazy evaluation is there. So one thing is there, lazy evaluation. So Spark supports lazy evaluation. So Spark supports lazy evaluation. When you trigger action, then only your transformation will be triggered. Okay. So that is lazy evaluation. Okay. So when I call the action, right, when I'm calling the count, right, so then my action will be, or when I do for each, okay, then will be triggered, or collect. So any one of them I will use, then your, otherwise it will not do any calculation. It will store it in the DAG, but it will not do the calculation. The final calculation will be done when you call the action. Okay. So this is the one program. So suppose if my file is a CSV file or some other JSON file or this one, so I will get the data frame API. But RDD also I can convert into the data frame, but I need schema. So I can say data frame is there is a either way is if you have RDD plus schema, or we are reading from JSON, CSV, XML, okay, Parquet, ORC, Avro, these all kind of files if you are reading, or SQL databases, no SQL databases. So this will be giving directly the data frame. So data frame can be created two ways. Either you have RDD plus schema you associate, you can create data frame, or you are reading the files, you can get the data frame. So I show you the RDD example while reading a file. I have not shown the example, like suppose I have an array and I want to create a RDD. So how to create a RDD of the array? So it's the same way, like you have a parallelize function. Okay, we can use the parallelize function to create RDD. Okay, suppose I want to do the similar program in the PySpark. Okay, so here I start the PySpark. So suppose I want to read the same file in the PySpark. Okay, so here I say RDD equal to spark context text file, and same file path I will give. XYZ. Here I got the RDD. Here I do RDD dot collect. So I'm getting the same thing. RDD dot count I do. Okay, always use the function way like this, open close bracket. If you don't do the open close bracket, it will give the object type. So now RDD dot count I got it. Next I want to do flat map. So RDD dot, like RDD I want to apply flat map. The function name remains same, even the function names and everything same, but only thing is here we have to use lambda in a different way. So how to use lambda here? Here is a lambda is a keyword. So lambda x, I say x dot split by space, Okay. So this is again I'm getting the another RDD. Okay. I told you RDD when we are doing operation, it will create a new RDD. I do collect. So whenever you do collect, then only you will get the result. Did you get it? Everything is a single code. It is getting the all word in a single array. So this is the one operation I did. Now the next operation, what we did there, map, right? So same thing I'm doing. Only thing is syntax is differ here. Here is the Python use lambda. So this lambda syntax is there. There Python I use. There I use X arrow equal greater than sign. This is the lambda sign. X greater than equal to greater. That is lambda sign. Here is the lambda is a keyword. Now I want to apply lambda. I say X, and I want to say each word I want to give one X comma 1. So this is my map. Okay. And then I do collect. Can you see? I'm able to see all word is coming 1 1 1 1 1. Now next thing what I did there, collect I remove. I did there reduce by key. So same I'm doing reduce by key. But now here lambda. Now lambda we need X comma Y, because reduce by key needs two parameter, right? Like at a time it will be using key and value. Okay. So here this is key X and Y is the value. And what I'm doing X plus Y. So this is my reduce by key, and then collect. If I do collect, so I will get the R is comma 2 time, fine is 1, hello is 1, how is 2. Okay. Now I want to print it. Instead of collect, I want to print in the, so print or for each collect is giving me word. Okay, how to iterate Python RDD. Python. RDD.for is println. It's simple here. So there we use _1 _2, but we don't need to do here. RDD dot for each, or otherwise like this we can do also. Color syntax. All Scala. That is a confusion. Okay. So when you have the any RDD, when you do RDD.correct, so whatever RDD you have, so you use like this. So you have to iterate each row and then print row of 0, row of 1. So here I have to, what is my RDD name? I have to change RDD. So my RDD is dot. Okay. I have to assign it to somewhere. So this collect I should not do. Actually, this operation is happening on the RDD, so I have to take it in some RDD1, some new RDD. Okay, because if I do RDD dot operation, that will not work out, because that now this RDD1 is my resultant RDD. All this transformation is stored in this RDD1. So when I do the final this one, I have to do RDD1. RDD1. So RDD1 I will iterate. Okay, I'll check it this Python one. Okay. So this way we can do some word count or some small code. So this is the practice purpose. So here is different transformation functions. So we have to use these all like PySpark and Scala1. Okay. So separate is there, right? PySpark is like a Spark session, Spark context, parallelize. Okay. So how to create RDD by using the parallelize function. Okay. Repartition, collage. So these are all. And if I'm going to read a file, so different types of files, read and write CSV file, JSON file, Parquet file, XML file, Avro file. So this is for practice purpose. So you can do this map function, transformations, aggregate function, windows. Okay, so these are all APIs function, join, group by. So first we'll do practice a Scala1. Okay, and then I will show the PySpark one. Okay. Okay, I'll share the recording in this notepad text. Yeah.
Thank you very much.
Okay.
Thank you.
Yeah.